Hey folks, I wanted to build on some of the stuff we've been talking about in the last couple of lessons. We've been talking about exponential functions and exponential growth and exponential decay. And one type of exponential growth is known as compound interest or compounding. And here I have on the screen the formula for compound interest, and we're going to get back to it in just a minute. But before we do, I want to talk to you about the practicality of this information. I believe that for a lot of careers, especially those in finance, no understanding compound interest and how to compute it is foundational. You must know it. However, I have to admit, for personal finance, there are some issues, and we'll talk about those real quick. So let's take a quick look at some things that, first of all, um, why do people care about compound interest? Well, it turns out there is a certain amount of magic associated with compound interest. Here I have some information that shows that if you start investing at age 25 and you invest $5,000 per year for 10 years and the money grows at a rate of 7% interest, you'll get a certain amount in the end. And if you start investing at age 35, same amount, $5,000 a year, but starting 10 years later, and you invest for 30 years, you'll get a certain amount of interest in the end. And the thing that's kind of crazy is that the first option is where you end up getting the bigger return. But you only invest $5,000 a year for 10 years. But the thing is, you started earlier. And because of compound interest, that 7% interest rate, starting earlier made it so your money just turned into a lot bigger amount, okay? If we can put together compound interest with the idea that starting to save at a young age is helpful, then who knows, maybe you could have a nice nest egg when you're ready to retire. Now, there's only one little well, there's several problems with my scenario here, but one problem is this. Sadly, right now, interest rates in savings accounts are very low. They're in many savings accounts, they're almost nothing. And even if you get something called a certificate of deposit or a CD, many of those have very low interest rates, nowhere near the 7% in my rosy scenario. So maybe there's other investment options. For one thing, some people keep money in brokerage accounts and they leave some of their money in money market funds. Well, again, those money market funds just aren't earning a whole lot of interest right now. So maybe something else. Well, there is this thing called the stock market, and the stock market does tend to produce better returns than a savings account, at least in this day and age. In the old days, not always true. Anyways, aside from the money that stocks can earn you through growth, in other words, the value of the stock goes up as the value of the company goes up. Aside from that, some stocks return value to their investors in the form of what's called a dividend. And a dividend is like a little bit like an interest payment. So for example, here is ExxonMobil. This ticker symbol is XOM for the stock. And you can see that according to this chart, they're listed at having a dividend yield of 8.23%. That's better than 7%. Now, again, there are other factors involved aside from just the dividend. It would be so nice if you could just buy shares of ExxonMobil and have them grow at 8% a year every year, and that was the only thing. That's a pretty darn good return. The problem is the price of the stock goes up and down, and right now the price of the stock is down because oil prices are down. But imagine for a minute that we were in an economy that was going through, and by the way, that where we're at right now is almost a bottomed out economy because of this coronavirus crisis. So many people believe the economy has nowhere to go but up. Not necessarily true, but some people do believe that. Well, certainly they believe that if you think about years in the future. So let's imagine that ExxonMobil, the price of the stock remained about the same, and that they continued to pay 8% return in dividends on the stock. Well, then we could go ahead and do some math on the return on your money, and maybe we could even talk about compound interest. By the way, let's take a look at something here. When we talk about calculating compound interest, there are several factors that are involved. First of all, I want you guys to notice that the formula looks an awful lot like the formula for exponential growth. Exponential growth looked like this, and what we said was this little a would be the starting amount of money. This y would be the amount of money you get after so many years, t. And this R would be the rate of growth, which could be a percent, like 7% or 8.23%. And that's how you do, and you would do a calculation using these numbers, and you'd get the amount of money that you would have. If you knew the amount of money you started with, you knew the growth rate or the interest rate, and you knew the amount of time, you could predict how much money you would have after so many years. Well, for compounded interest, it turns out that you actually can earn interest on the money earlier than 1 year. So, for example, some banks, and certainly if you get dividends in the stock market, you get paid your dividends more frequently than once a year. So what happens is if you let that money go back into your brokerage account, then you get paid dividends on the dividends, and that's exponential growth. And it's also compound interest. So what I'd like to point out is this formula is very similar to this formula here. P is going to be the starting amount, also known as the initial principal balance. R is going to be the interest rate, just like we said before. A is going to be the final amount, just like Y was the final amount here. And T is going to be the amount of time. The thing that's different is this N guy. This is a little different, and it appears here and here. And the reason why we have that N guy in there is because what happens is with compound interest is you have to, let's say you want to pay the interest 4 times a year to somebody. You would have to divide the interest rate by 4, and then you would have to apply that interest rate 4 times a year. So 4 times whatever the number of years, okay? So that's where the N comes from, is it depends on how often we compound the interest in a given year. So let's take a look and see some common values for N. So for example, let's say that we said that we wanted to pay interest, or we wanted to receive interest on what's known as a, let me think about this. Let's do it on a monthly basis. If we wanted to receive interest compounded monthly, then N would be set equal to 12. In other words, we would divide the interest rate into 12 parts, and we would multiply the numbers of years times 12. Because for instance, if you had the money in for 2 years, you would compound the interest 24 times, once every month for 2 years. So if we wanted to compound monthly, N would equal 12. If we wanted to compound quarterly, there's a thing called quarterly. And if we wanted to compound quarterly, then we would say N is equal to, well, how many quarters are there in a year? I hope you're guessing 4, okay? And if you are, then we would say N equals 4, and that'll give me then I would divide the interest rate by 4, and I would multiply the number of times that I compound by 4, the number of years. So if it was 1 year, I would compound 4 times. If it was 2 years, I would compound 8 times, 4 times 2. Okay. So it's also possible to have daily compounding. And what do you think it would be for daily compounding? What do you think N would equal? I'm hoping that you guess 365, because there's 365 days in a year. For you scientific minded, you know it's not exactly that, and that's okay. And some of you might say, well, what about leap year? But we're going to say this is probably a pretty reasonable guess using some common sense. What about weekly? What if we wanted to compound weekly? And I'm not saying that a lot of places do this, but I'd like you to guess what n would equal. You can pause the video and take a moment and guess. Okay, I'm hoping that you paused the video and guessed because I'm going to tell you the answer. I believe that for weekly n would be 52. In other words, we would divide the interest rate into 52 parts and compound 52 times a year. Okay, now let's get in and let's try some sample calculations, and then I'll give you some homework where you can try the calculations yourself. All right, we're going to go ahead and try to do a calculation using this knowledge about the compound interest formula. But instead of me going back and looking up the formula, I'm going to try to see if I can recreate it from my memory using like some techniques. So one thing that I would like it if you could remember is what an exponential growth or an exponential decay function looks like. And since we're talking about growth, we'll talk about a function that looks something along the lines of this, okay? And then we're going to see if we can just expand that into compound interest. So compound interest has an amount that you get after you start with a certain amount of principal, and you take one and you add it to whatever the interest rate is, except the interest rate we're going to divide up into n parts. And then we're gonna multiply that over and over again, just like we did with exponential growth for whatever number of years, except again, now it'll be for all the different times in the year as well as number of years. So it'll be n times t. Okay, so there we go. So that's how I remember the compound interest formula. Now, let's go ahead and apply it and do some math. So here we're talking about investing $5,000 a year for 10 years at an interest rate of 7%. And we're just going to play around with this. We're going to make up some stuff, okay? First, let's just try it just as it says. What we'll do is we'll compound annually. And if we compound annually, n for annually equals 1. So in other words, we don't have to worry about this n, and we don't have to worry about this n. R divided by 1 is R, and 1 times t is t. So we're going to say compounded annually. And just to make sure that you have this written in your notes, and you should be writing this in your notes. There we go. The word compounded and the word annually. And in this case, we'll say what n is when we compound annually. It is equal to 1. So therefore, if we want to figure out what you would have after 10 years, investing $5,000 a year at 7% interest, you would do A equals the initial amount. Ooh, that's an interesting one. They don't say what our initial amount is. All we say is we invest $5,000 a year. So what we're going to do is we're going to just say investing $5,000. So we'll say forget about for per year. We'll just say you invest $5,000 and you let it ride for 10 years. And every year when you earn interest, you reinvest the interest. So you're earning interest on interest on interest. That is the beauty of compounding. Okay, so our initial amount is going to be 5,000, and then 1 plus the interest rate is 7%. So as a decimal, we write that as, ooh, why don't you pause the video and then you can see if you agree with me. Okay, I hope you paused it, I believe that 7% will be written as 0.07. We divide by 1, and I can do that if I want to, or just forget about it. And then we raise that to the power of t, or number of years. In this case, it's going to be 10. And then we go ahead and do the math and figure out whatever that is. Okay, so I'm about to show you the calculation, but before I do, I would like it if you could try the calculation on your calculator, and let's see if we agree. I'm going to wait for you to pause the video, and then I'm going to show you what I got. Okay, I hope you paused the video. Here we go. So what I did was in my calculator, I added 1 plus 0.07. I got 1.07. I raised that to the power of 10 because I did PEMDAS. I did everything in parentheses first, then exponents, then multiply. So 1.07 to the power of 10, and that was like 1.97 approximately. And then I multiplied that times 5,000, and I ended up with 9,835 and 76 cents. So, in other words, in the end, I ended up with about $9,800. So I made about $4,800, almost 5,000 bucks. I doubled my money. That's not bad considering all I did is put the money in an investment. It wasn't me working for the money all those years. That's kind of nice. That's the beauty of investing. Okay. So that's doing it annually compounded. Now, I'm just kind of curious. We're going to try some other compounding periods and we're going to see what answers we get. And then you're going to try some practice problems. Okay, so for the next thing we'll try, it's going to be compounded quarterly, and I would like you to try to remember what n is for compounded quarterly. And don't cheat by looking at your notes. And in a minute, we're going to try another one, and again, I want you to see if you can remember what n is, okay? So compounded quarterly, hope you can pause the video and try it yourself. Okay, I hope you paused it, and I hope you agree with me that compounded quarterly will be n equals 4. With that idea in mind, we should do something like A equals $5,000, the original amount. Okay, this time the math will be different. We're going to do 1.07. We're still going to add 1 plus 0.07. But this time, instead of doing 1 times 10, we're going to do 4 times 10. So that's going to be kind of interesting. We'll see. Oh, there's another thing we got to do. We got to fix something. I can't do 1 plus 0.07. It's got to be 1 plus 0.07 divided by 4, so let's fix this. It's going to be 1 plus 0.07 divided by 4, whatever that is, and we'll raise that to the power of 40. Okay, so let's go ahead and you try to do the math on your calculator. I'll try to do the math. Pause the video. Let's see if we agree. Okay, so if you did the math, by the way, I'm going to give you some tips about how I entered it in the calculator. And if you still want to pause the video before proceeding, you can and try it yourself. I went and did the 0.07. I did the dividing of 0.07 divided by 4 first, then added 1. Remember, I'm still following PEMDAS. Divide before adding. And do everything inside parentheses first. Then take that amount, raise it to the power of 40. Exponents next, parentheses, then exponents, then finally go and do the multiply. And again, I'm doing this dividing and adding first because they're inside parentheses and I have to do parentheses first. So I'm using PEMDAS inside of PEMDAS. Okay, with that idea in mind, you can pause the video and try it on your own, or let's check and see. Here we go. I'm about to show you mine. So here's what I got when I did the math. I came out with $10,007 and like 99 cents. I forgot to write down the previous amount. It was something like $9,800. And now we're getting $10,007. So we made about $200 more just because it was compounded quarterly. So I'm going to go ahead and write down this amount, about $10,007. And let's see here, if we round, it was about 10,008. So let me see if I can get this. Oh boy, I am having some problems writing. Sorry guys. 10,000 and roughly 10,000, but I'll throw the 8 in there just for the heck of it. And that's 200 bucks more for compounding quarterly. Let's try one more together, and then I'll give you some practice problems to try. Okay, so now we're going to try compounding daily, and I'd like you to see if you can remember what n equals when we're compounding daily. Go ahead and pause the video if you need to. All right, I'm about to tell you. Here I go. N equals, for daily, we're going to say 365. So this is going to be kind of interesting. Let's go ahead and do the math and see how it works out. Oh, before I write any more, I want to see if you can finish off writing this out yourself using the example that I gave you for compounded quarterly. Pause the video, see if you can finish it, and then I'm going to then start it up again and let's see what I have to say. Okay, here I go. I'm about to give my opinion on this. I'm going to take the 0.07 and I'm going to divide it by 365. That's my n. And then I'm going to raise that to the power of n times t. So 365 times the 10 years. So times 10. And then I'm going to go ahead and punch this all in the calculator and see what I get. I'd like you to pause the video and try it yourself and see what you get. Okay, so I ended up getting about 10,068, about 10,068, and that's dollars, and I'm hoping that's what you got. Just again to clarify what the way I did this to get the right answer in the calculator, I did the 0.07 divided by 365 first, added the 1 to that, took that result, raised it to the power of 3,650 or 3650, and then multiplied that result times 5,000. I hope that's what you did. And if not, I'd like you to go back and retry it so that you can get this right. Now, let me show you a couple problems that I have for you for homework for you to do. So I'll give you credit for giving me video notes for copying these down, taking a picture and submitting them, but I also want you to try a couple problems, and here we go. So the first problem is, what if you invest $4,200,000 for 10 years compounded annually? I'd like you to calculate, show the calculations, and then give me what you get as your result. Then I would like you to tell me what happens if you invest $4,200,000 for 10 years compounded monthly, and tell me what the result is that you would get, okay? And then finally, one last one, let's go for 3. You will invest $4,200,000 for 10 years, and you will tell me what you get if you compound quarterly, okay? So 3 problems for you to do. I apologize that this video went for so long, but I am hopeful that you found some of it to be interesting, and I certainly hope that this will be useful to you at some point in the future, because compound interest is relatively practical math. All right, folks, good luck. Oh, don't forget to do the math, show the work, show the answers, take the picture, and upload to the Google Classroom along with the notes.